You can see that by a simple HTML iframe, we take in the source, point it to a local file on the victim file system, and having a very simple JavaScript that basically take the content from the iframe itself, and basically we have access to the file. We can now manipulate it, touch it, and do whatever we want upon it. But with iframe, things weren't so easy. We have encountered two major issues when we started playing with the iframe HTML tag. First one, that iframe HTML tag has required us to implement some sort of a busy waiting procedure, which means when we try to fish bigger files, we had to wait for the entire file to be buffered and displayed on the iframe. Now, if it was our only problem, we could have been just do a simple workaround. But the second issue with iframe is in the terms of the way the browser looks and reacts to an iframe, is like it reacts to every other link, regardless to the origin of it. So when we try to access, let's say, a Word document, one of the two has happened. Either the user has been presented with the open as, save as dialog, or Firefox would have been launched Word on the computer with the data in it. Either way, we wouldn't have any access to the target file, and we also just gave ourselves away on the victim computer. So off goes iframe, here comes Ajax. We started to look in further to see how we actually can manipulate other functions to read data from the victim file system. And we basically just found Ajax. Ajax is not emotionally or mentally attached with any file types or URIs. Being a backend technology means that we don't have to involve any external application in the process. We can simply keep it within the boundaries of Ajax itself. Now, here's an example of a simple Ajax socket request. You can see that we are creating a new XML HTTP request, following by an open, a pseudo get on the victim file system. The second parameter here, the dot, represents the Unix syntax current directory. And what's the result of this query? We will get the entire files in the resource folder where hidden window resident in. Taking it a step further, we can now perform simple string subtracting on the output, and the result will be that we will be able to gain an information to where we are located on the victim file system. Now this helps us to achieve two goals. First, we can now navigate in the victim computer. We know which directory it has and where we are located in the tree. And the second feature is basically to reach a complete automated jailbreak procedure. As I mentioned before, we need to give the path to the file URI to point to the hidden window location. Now through this small Ajax function, we can basically discover hidden window in runtime and put the last nail in the cross-platform feature. But with Ajax, things weren't always so peachy. Ajax been designed and programmed to handle XML and HTTP requests, which both by nature are text. And we wanted to read everything. We wanted to read Word documents, text files, pictures, you name it, we wanted. So we had to find a way to overcome this obstacle. Now, as I said before, Ajax, being more programming-oriented feature, being part of the Java framework, allow us to solve this issue in a very polite programming way. Here you can see, assuming we already have an Ajax socket utilized before us, we simply call the file.override MIME type method, changing the char set, which by default does not support binary data, to one which will allow it, and we will now be able to access and fetch binary streams through Ajax, all in a very polite, clean, non-patchy way. Okay, so far, in theory, we know how to download files from a victim computer, but it's not fun if you cannot transfer them back to our server located somewhere in the deep web. Now, We have tried different methods to get the information outside of the victim computer. Our first attempt was naturally to go back to Ajax. If we're already using Ajax to read information from the computer, why not using Ajax to basically smuggle it out? Well, think about that when we start to manipulate with this function, we came across a very known feature, security feature of Mozilla called the same domain origin policy. Now, the same domain origin policy basically means that two separate websites coming from two unrelated domains cannot communicate with each other. Now, hidden window being part of the file domain on the hard drive of the victim trying to communicate with an HTTP something site deep in the web is a very bold and clear violation of this rule. So we couldn't use Ajax for this purpose. Moving on, we thought about faking an HTML form. An HTML form will basically submit data outside of the victim computer. Thing is, the browser is programmed after submission to redirect the user to the result website, which means we only manage to do it once before we will lose hidden window and get it redirected to an HTTP website. Now, HTTP website cannot go back to claim to be a file because it will be simply a security violation. So the HTML form was no good for us. What's the way we did manage to find it was through iframe. How we did it with the iframe? Well, thing about iframe is it does partially ignore the same domain origin policy. It will allow you to communicate with the server, which breaks the same domain origin policy, but it won't allow you to peek into the information, the result, coming from the server. But in our case, we're not interested to see what the server will reply. We only want to create a socket and move the data outside. Now, iframe being limited to GET request, we had to use the URL as our buffer. In that position, we can push up to 2K of information in every time we create an iframe GET request. Now, if we want to speed things up, we only have to, you can easily make it parallel, open multiple iframe tags, and the file will be splitted and transferred in parallel. As far as the server concerned, all we had to do was to build a simple PHP file that reassembled back the GET request into a single file on the server side. Now, handling with the URL, it's basically a known territory. People already mess with it, and the problems there are probably well mapped. The URL does not support native binary characters on it. We cannot simply push images and binary files in the URL itself. The solution, quite simple. All we had to do was to encode the information on the URL itself. You can see here an example of encoding methods, quite popular ones. Base64 is used for email attachments, the escape function written for URL binary purposes, and just plain convert every character to hexa in a head. All these encoding methods can basically allow pushing data binary over the URL. Each has its own price. Okay, so right now we have demonstrated the ability in theory to read files and to smuggle those files to an external server. Let's talk about what happens in between. Let's talk about the process that goes before the I and the O meet together. Well, after some experiments, we have started to discover that Firefox is acting quite strange for our machine. It became heavier, slower, the memory consumption has gone off the roof, and the CPU cycles were very demanding. We have reached a conclusion that basically we have abused Firefox. Firefox was never designed to handle such a massive sub-application in it. So, unable to change the way Firefox works, we had to change how we're going to work on it. Now, when we first designed Jinx, what we had in mind was a one-shot execution. Every time will be executed at once, read file, and immediately write it to the server, going over again on all the targets that the malware is looking for. What that caused basically is that Firefox was unable to execute its garbage collector and other memory-related feature to balance it. So over time,